Okay, I think we're broadcasting now.
We are. Let's give everybody just a minute to get on and make sure that everybody's taking care of their Zoom stuff, and then we will get started in just a minute. Okay, I think we'll go ahead and get started. Good afternoon. This is Julie Hibben with the Iowa Department of Public Health. We want to welcome you to our webinar training this afternoon. This has been one webinar in a series of trainings we've been hosting through our AmeriCorps program here at the department. And so this afternoon we are going to be focusing on social math, making data make sense using social math to communicate your message. And our presenter is Shayla Meister. Just a couple reminders as we get started today that everybody is going to be in mute, so you can't just verbally express a question, but if you do have any questions throughout our time together today, just go ahead and use the chat box. I believe there's also a questions and answer box, and you can utilize that as well. Also wanted to remind you that we are recording this session, and we will be sending out the link and the PowerPoint presentation probably a couple days after the webinar occurs today. So just know that you will be receiving that information. We are sorry about the late start. We had a few technical glitches, but I think we've got them all squared away now. So I will go ahead and turn it over to Shayla.
Thank you. Hi, everybody. And again, thanks for joining us this afternoon, and welcome to the Using Social Math to Communicate Your Message training. Like Julie said, I'm Shayla Meister. I'm the Marketing Communications Manager for the Iowa Department of Public Health. And my goal today is to get you excited about the concept of social math. It's one of those things that I think is easy to use and easy to understand. And it is another tool for your toolbox to help you communicate your message to your audience. So hopefully this will be something that you can actually take away and use in your work. Hopefully it's not one of those things that you just kind of hear about and are like, I'm not going to ever use that. First off, I'll let you know that I didn't create social math. I may not even be an expert in social math, but I have used social math in publications and messaging, and I have found it to be impactful in getting data points across to my audience and segments. I think as we go along, you'll realize that social math may not be necessarily a new concept. I think it's just something that they're branding now as social math and is gaining popularity as a way to communicate data. So as we get started, kind of think about all the different ways that you communicate data now. You know, a lot of times we use charts and graphs, narrative, reports, infographics, and even advertising and so forth. But think about how many of those actually work in getting your data message across. Is it making your data memorable? There are pros and cons for all of them, of course, depending on who your audience is, depending on what your goal is. So kind of think about that as we go through and talk about social math as well. And I can't tell on my screen, but I always ask how many people have heard of social math or are using social math now. So if you want to type in the chat box, and maybe Julie can see those, how many of you are doing that right now as we move forward? So just a shout out before we get started, this presentation was adapted from something that was done by the CDC and FHI 360. It was originally done for a 2-day training with the Iowa Community Transformation Grant, if any of you were involved with that. And they've allowed me to adapt their materials and use the information for the webinar today. So just a quick disclaimer on that. So today we're going to look at how we connect data and stories to communicate, using target audience methodology to do so, and we'll learn how social math can help communicate data both visually and linguistically. So how can data be used, or why do we use data to communicate public health messaging? We use data in communication for our program purposes in many ways. One, it shows our practices are evidence-based, which is very important in public health and other prevention work. It helps shows legitimacy. It helps shows that we're credible, that we know what we're talking about, and that we're experts in the field. It also helps convey programs' importance. In some ways, it can help, or not really help, but it can be used for spin. And we all know about spinning messages. We're still in the aftermath of the election of 2016, and we can still remember how data was used to portray messages for each candidate or for each issue. Also, with all of the talk of fake news that goes on, data can be skewed for those purposes as well. However, some thematics from data can really show three things. One is gloom, that our program is needed, that things are bad, and that we can use data to maintain or raise awareness. It can also show control and hope, that our program helps or is the solution to a problem. And it can also show success, that our program does great work. It can also be used as an evaluation tool to show the success. However, there are a few barriers to providing health information or health data. As you know, not everybody understands health information. Health literacy is always a problem. Only 12% of US adults have proficient health literacy skills, and over a third have trouble with common health tasks. And anyone can have limited health literacy skills, regardless of education level. And if you think about it, even with us, we're probably all highly educated. There are certain areas of health where we're very proficient in our knowledge, and then there are other ones where we don't have a lot of information or a lot of experience in. So health literacy can be an issue for anybody. Along with health literacy issues, not everybody understands numbers. Everyone knows not everyone learns the same way, and so not everyone understands numbers the same way either. Some things to remember are health literacy skills do not equal to numeracy skills, or the ability to understand and use numbers. And half of the population has problems with simple numeric tasks. People can only retain 5 to 9 new pieces of information at a time. And think about how much information you usually put in a report. It's usually more than 5 to 9 pieces of information, right? If you were to go to and tell your boss right now, hey, I'm going to write a report and it's only going to have 2 to 4 pieces of data in it, they're going to tell you to rewrite it because that's not the typical way to do it. Also, more data does not necessarily equal in a better argument strength. And I think a lot of times we're often in the mindset of the more data, the better. We build it like a legal case. And it's kind of like, I'm going to prove to you right now how right I am by hitting you with all this evidence. And then you'll be so compelled by all of the facts that I'm giving you that you'll agree with me, you'll make the changes that I want, and so on and so forth, and you'll live a better life. But it doesn't work that way. Often when we use too much data, we just kind of dump it into the report. And what this does is it requires the audience to find the importance of the information themselves instead of us controlling the message. We do this a lot with charts, where we, again, just put all that information in a chart, and we require the person to figure out what we're saying instead of crafting the message with data. Part of this is we're uncomfortable with data ourselves, I think. We kind of think, am I using the data right? Is it still statistically correct if I just take out one piece to highlight what I want? And so we're kind of confused by it. We're kind of awkward with it. And so our answer to it is we'll just put everything in there to make sure we cover our bases. In doing that, we're requiring then the audience to do the work instead of us. And when we do this, this confuses the audience. Again, it requires them to sift through all that information and figure out what we're saying. So instead, we really want to craft and control our message. So how can we make our data more relatable and understandable? We need to tie it to narrative and emotion. Symbolically, data is considered more about the head. It's thinking, it's analyzing, it's measurement, it has very much exactness. However, this can be difficult to personally relate to data. This makes it cold, it doesn't make it memorable, and it doesn't spur behavior change or action that we want. On the other hand, stories are the heart symbolically. They are considered more emotional, more feeling. You can tie it to personal lives and anecdotes. Think about how many times you use testimonials and how purposeful those are in reports. Stories can be more relatable, but they can also be less compelling because it isn't necessarily tied to evidence or research. So again, it's not maybe seen as credible. So the magic of social math is that it ties the two together to communicate data. It appeals to both the head and the heart, uses both data and narrative. So here's an exercise, and if this was data that I was trying to present to you, and the goal was to have you remember these letters in order, could you do it just by reading it this one time? If I gave you 30 seconds or a minute, and even if you could, even if you had a super great memory, could you remember them in 2 days' time? You probably couldn't, right? Now here are the same letters in the same order, only grouped together in a different context. Is it easier to remember the letters now? Would you be able to remember all of it or even parts of it in 2 days' time? You'd probably have a higher chance than you would in the other way that the letters were presented. And why can you? These letters are obviously grouped together in acronyms that you are well familiar with, making it easier to remember. I mean, we all kind of are familiar with JFK and FBI and NATO and so on and so forth. So it plays to the context in which you already know, making it easier for you to remember. By grouping the letters to things that you're already familiar with appeals to you, the target audience, as well. And it, again, makes it easier for you to remember the numbers. So the point of this exercise is to show that context makes the difference in what people remember. So here's a common way that we present data. We love tables, right? We can show all of our data. The audience can find an increase or decrease of the measure of our success or whatever, right? However, there are a few possible problems for health literacy or numeracy issues here. Again, would this be memorable to your target audience? Is it relatable? Um, would it want would it make you want to choose a healthier food option? This is about obesity, or to exercise more. After a while, in a chart like this, it can just look like a lot of similar numbers, right? To the layperson, it can just look like, yeah, it went up 6+ points or whatever, even though to insiders, that may be a significant increase. So without human context, the data becomes meaningless, and data alone can leave audiences with no sense of taking immediate action. Like this wouldn't make you do anything. And because data is important, the way we present it should be something that can help impact behavior changes, because we're doing all this work on it. So if we're taking the time to collect the data, let's also present it well. On the other hand, anecdotes without data don't necessarily have the same weight. You lose legitimacy, and again, it doesn't necessarily prompt the audience to feel motivated to do anything. So the point is, again, that you need both data and contextual story. And I always state when I give this presentation that I love this picture because it shows this woman. She isn't compelled to take any action. She just kind of looks complacent. And she may be having a lot of feelings right now and moved by a story, but that isn't going to make her stop from leaning up against this building or whatever she's doing. So providing context all depends on who your target audience is. And you guys all know about target audiences. Think about all the different audiences and segments that you have just for your program. You often tailor your writing to them or how you deliver services to them to appeal to their own situation. And you may have different tactics in presenting to consumers than to providers or stakeholders or legislators and so on and so forth. And so we also need to tailor then how we present our data to these individual audiences. So again, tailoring the data to your audience makes a huge difference in their understanding and memory. Some things to consider are we meeting their needs when presenting data? Do we have what the audience wants or needs to hear? What are the best ways to provide this information to them? And I like this slide too because it alludes to the fact that social math may not be the best method for all situations. So it may not be appropriate if you're writing a white paper or if you're submitting something to like a peer review scientific journal. Again, social math isn't the end all be all. There are pros and cons, of course, to every resource, and this is just another thing. It's another resource for you to choose from, depending again on that target audience. Finding your target audience or segment and determining what their needs are, and even what barriers they may have, will help you narrow down your messaging and how to present your data. But a lot of times we overcomplicate things, as usual. We overload things with data, make it full of insider jargon, and we make it confusing ultimately. And by doing this, we're shooting ourselves in the foot. after all the work that we've done on it. So some things to remember when you're conveying data are listed here. Keep it simple, informative, factual. Use concrete, discernible examples. Also, see how you can relate the data to your target. How can you make it personal to them? How does it relate to them? That will help make the idea stick. And if the idea is memorable, they'll have a greater chance to make behavior changes that you want. So 65% of people are visual learners in whole or in part, but the visual must be recognizable and of meaning to our audiences. Again, this is all about context. If it isn't relatable to that audience or from their own experience, it isn't as effective and it won't be as memorable. And it will change with each different audience that you have. So I kind of touched on this in the intro, but there are many different ways that you can represent data. And the next few slides are kind of going to go through different ways that we do this. And show the same data. Again, all methods have their purpose. And for this exercise, we're kind of seeing how social math works, though. So we'll look at a few common ways to present data in messaging with social math example at the end. And while we're going through these, think about which one you think may work best in being memorable or relatable. And in this example, it focuses on nutrition, which I know isn't your field, but I think it's a good example to review. And I think as the target audience, you'll hopefully be able to relate to it if you go to the movies. So the purpose of the data is to encourage healthier snack choices at the movie theater. And in this method, it's a data report, and it uses narrative and bullet points. And it says a typical medium popcorn at the movie contains 60 grams of saturated fat and 1,160 calories. The second bullet says the USDA recommends no more than 20 grams per day of saturated fat. So this is a common way that we present data in narrative form. It uses bullets to break up the text. We love bullets. It provides more white space, which they always say is a great thing to do. But would this impact an audience to make a healthier snack choice? Is it easily memorable? And I always think of a 2-day test. If your reader actually read all this, consumed it, would they remember this information in 2 days? Would this spur them to make a change? Maybe not. So here's the same data shown in a different way. It's shown in a chart, right? Again, it shows that there's 60 grams of fat for movie theater popcorn versus the recommended 20 grams of fat by the USDA. And think to yourself, does this improve upon the last method of narrative only? And how does it? Well, you could say that it's more visual, so there's less reading, but you can still see the easy distinction between the 60 grams of fat and the 20 recommended grams of fat. It also uses a bright color in orange, and there's just less reading. That's always a plus. So, but you have to think, would this table, again, influence the audience to make a better snack choice when they're at the movie theater? Do you ever go to the movies and say, you know what, I'm not going to have popcorn today with the butter and all of that because, I saw this really great orange bar chart the other day? No, that's probably not going to happen, right? So how can we get the data to be more memorable? Another way that we can show data is through this way. This is kind of a pictorial way. It's used commonly a lot in infographics. And it's showing, an increase, the 300%. The arrow's going up. It's quite large. It's orange again. And it says a typical medium movie theater popcorn has 3 times the recommended daily allowance of fat. And again, it's shown with a picture of popcorn, so you're thinking of popcorn as you go along. And again, would this impact a moviegoer's choice in snack foods? Would they make a healthier choice? Maybe or maybe not. So here's the social math example. And it says a typical medium popcorn at the movies is the same as 6 eggs with cheddar cheese, 4 strips of bacon, and 4 sausage links. And then again, it uses pictures of the food. Does this improve upon the last methods of communicating data, and how? How impactful is it in presenting data this way? It strongly emphasizes the argument that movie theater popcorn is not a healthy choice. Did anyone think while I was reading that, like, oh my gosh, that's a lot of gross, greasy food, or yuck even? It creates an image in your mind of what that is. So would this way be more impactful to an audience to possibly change their snack choices? Does it make it more memorable than maybe the other 3 ways that we presented data? So social math places the data into a real-world context that our audience easily understands. In the last example, we know that eating eggs with bacon, sausage, and cheese is not good for avoiding saturated fat. Even if you don't know the exact fat content of each thing, you know that they're not good for you, even one of those things. And we immediately understand that the popcorn has a lot of fat in it. There's no calculation or study on the audience's part, and that's how social math is effective. It relies upon what the audience already knows or perceives. And in this slide, audience is underlined to remember that it's their viewpoint and not ours. So here's another example. In 1991, enough alcohol was consumed by college students to fill 3,500 Olympic-sized swimming pools, and the amount spent on alcohol exceeded dollars spent on books. It was far greater than the combined amount of fellowships and scholarships provided to students. And so can you immediately picture that this is a lot of alcohol used? Even if you don't know the exact number of how much water an Olympic-sized swimming pool is, it gets the point across that it's a large amount of alcohol. And also note that, again, the social math equation was accompanied by a related photo, which again helps with context and memory. Here's another example. The tobacco industry spends more money promoting smoking in a week than the federal government spends on preventing smoking in a year. And I like this example because it makes a point, and it gives a social math equation, but it doesn't use any actual numbers, although it is data-based. So when doing this in social math, you always need to cite your sources, as they do at the bottom there. Again, some of these can be seen as merely statements, but they are actually real data points. So how social math works. It emphasizes your argument or point of view on an issue. It makes it important, urgent, relevant to your audience. It uses comparisons. If you think back to elementary school grammar, it's kind of like doing a metaphor and a simile where you're making a comparison between two things. It can compare with things like dramatic events that people know about, like Hurricane Katrina. In Iowa, we always talk about the flood of '93. World War II is another big one. We also focus on costs a lot. This is a big one for stakeholders, legislators, other people you want on board with your program and to give you funding a lot of times. We also make comparisons with relevant issues. If you look at the prescription medication one up there, that's one that's used, that can be used, or topical areas that are important to your program or audience. If you're trying to appeal to physicians, you can tie it into their practice or healthcare. If you're appealing to new moms, you can tie it into babies, bottles, blankets, school, whatever. If it's about nutrition, again, it can tie into food and obesity, physical activity, things like that. So again, finding the context that works for your audiences and then using language and images that will work for them. So some things to help you get started. I always get asked, where do I get started when I'm doing social math? And this slide, I think, really helps out. You have to think about who or what does it impact? How much money does it represent? How much time does it represent? What resources does it use or save? What size is it? And how might it be compared to a place or an event? These things will help you determine what comparisons to make in your social math equation. And the 4 simple steps of using social math are identify the key data point to share with your audience, convert any percentages into numbers. Social math only uses raw numbers. Find your comparative data. Again, it's numbers, not percentages. And then create your equation. And then, of course, the 5th unofficial step is to cite your sources. So we'll walk through a few examples just to get the point across. And this one is about gambling. If 68.1% of adults in Iowa reported gambling in the past 12 months, and the total number of adults in Iowa is 2,318,362, then the estimated total number of adults in Iowa who have reported gambling in the past 12 months is 1,578,804. So to do the math, it's pretty simple, the math part. You take 0.681 times the 2 million number to get 1,578,804 as the number of adults in Iowa who have reported gambling in the past 12 months. And so the social math equation is that's more than the total number of passengers over 14 months who boarded flights at the Des Moines International Airport. So hopefully what that does is it resonates that that's a lot of people. So let's do another one. Another gambling one. If 22.6% of adults in Iowa report that they know a person with financial, physical, or emotional problems caused by gambling, and the total number of adults in Iowa is again that 2 million number, then the estimated total number of adults in Iowa who know of a person whose gambling is causing problems is 523,950. So again, the math is you take 0.226 times the 2 million number to get 523,950. And the social math equation for that is this is more than 5 times the daily attendance at the 2015 Iowa State Fair. And so again, this is thinking about what landmarks are relevant to your community or to the audience. And the Iowa State Fair is always a big one. I think everybody knows, even if you don't go to the fair, that the daily attendance is pretty high. And it's also, again, supplemented by a photo of the fair. So hopefully it plays into the context, if your target audience is Iowans, that it's a large amount of people that's affected. Here's another example. Youth tobacco use in Iowa. If 18.1% of youth in Iowa are current smokers and the total number of youth in Iowa is 722,634, then the estimated total number of youth smokers is 130,796. So again, that's 0.181 times the 722,000, and you get the 130,796. So the social math equation is the number of children under the age of 18 who are current smokers could fill more than 2,515 school buses to capacity. Those buses would stretch more than 19 miles if lined up end to end. And how many of you then pictured school buses lined up in your mind when this was read? Again, since most people are familiar with school buses, it's easy to get a mental picture of the numbers. And why do you think school buses were an appropriate thing to use as a comparison? It's because it's about children, right? And so a good audience for this would be maybe parents or teachers or legislators. And again, using this evaluation, using this comparison for the right target audience. Here's another example. If 18.5% of adults in Iowa smoke, and the total number of adults in Iowa is that 2 million number, then the estimated total number of adult smokers is 428,897. And again, for the math, you take 0.185 times the 2 million number to get 428,891 total number of adult smokers in Iowa. And for the equation, that's enough to fill the University of Iowa's Kinnick Stadium over 6 times. Again, this is trying to show that it's a large amount of affected people and trying to create a picture in your mind connecting with this context that you already know, especially if you're a Hawkeye fan. Here's another example. If 24.7% of people ages 18 or older report that they have engaged in binge drinking in the past month, and the total number of adults is again that 2 million number, then the estimated total number of adults in Iowa who have engaged in binge drinking is 572,635. So again, the math is you take 0.247 times the 2 million number equals 572,635 as the total number of adults who have reportedly engaged in binge drinking. For the social math equation, that is more than the enrollment at all of the Big Ten schools, which is 14 universities combined. Again, this is trying to show that it's a large amount of affected people. And if you consider a university as a large amount of people, let alone 14 of them together, that's quite a few people that are affected. So hopefully that gets the point across. So what I would like to do, and I'm not sure how well it'll work over the webinar, is kind of give you guys a sample social math problem to do and maybe take about 10 minutes away and have you guys come up with your own comparison data. So we'll see how this works. So here's the exercise. For the purpose of this, let's say that 10.3% of adult residents in your city, town, county, or whatever region have sought treatment for substance abuse, and the average cost of a month's treatment is $4,200. And these are just all made up numbers. So by using your smartphone, I don't know if you can use your computers while you're on the webinar as well. You need to find, first off, find the population of your city, town, county, or region, or whatever you choose. And here are some possible places that might have that information. And then next, you need to calculate that number that represents 10.3% of your population. So again, you'll take whatever the population number that you find and take it times 0.103. And then whatever that number is, you'll need to multiply it by the 4,200 to get an estimated substance abuse monthly treatment cost. Once you have that number, you'll need to find some comparative data to compare it to. And always think back to your guiding questions. Who or what does it impact? How much money does it represent? What resources does it use or save? What is its size? And what can it be compared to in a place or an event? And also, who would you make this argument to? Think of that as you find your comparison topic online. I always think about some people compare it to like, oh, this could buy 105 Ferraris, or this could buy 20 cases of champagne, and think about, is that appropriate with what I'm trying to convey to the target audience? So if this works, what I'd like to do is, again, take about 10 minutes and kind of do this really fast and maybe find some comparative data, and then maybe report back out in the chat section if some of you could. And I'd like to know who your target audience is, what region did you choose to do, and then what your social math equation is. So if we could take 10 minutes, please come back because there are a few final thoughts and we'll kind of go from there.
Shayla?
Yes.
Can you say that one more time? So target audience, I'm going to just type this into the chat so everyone
Sure.
can see it.
So who is your target audience? What is the region that you chose? Was it a city? Is it Des Moines? Is it Iowa? And then what your social math equation is.
Okay, great.
Thank you.
Shayla?
Yes.
So there is a question in the chat from Lori. Can you give the original stats again, the costs, etc.?
Oops. Does that help?
I think that's what she is asking.
Okay.
Lori, let us know if that's not what you need. Yep, she said that's what she needs. Thank you.
Okay, great. Okay. Is everyone back? Um, Julie, is there a way that I can see the chat, or are you the only one that can see the chat?
If you can see it, it should be on the right-hand side of your screen, like a little further down. If you maybe exit full screen, you should be able to see it. And if you can't, I can read things to you. It's totally up to you.
Okay. Okay. I think I can see it.
Okay.
Okay. Hopefully everybody's back. We'll just try and reconvene and hopefully read some people's examples. And I am seeing in the chat that some of you are already using social math, which is great, or have heard of it. Okay. So here's one example that somebody typed in. Thank you. The population is for Emmett County, Iowa. The cost of treatment for 1 month would be $4,326,000, and this would pay for 970 LE officers' salaries, with the basic pay of, I'm assuming, of $53,490 for 1 year. So I think that's great. I think, again, if you think about 970 people, that's a lot of people. So it's showing that that is a large amount of money. So I think that's a good example. Does anybody else feel brave enough to share their example? If I could get a couple more, that would make me happy. Okay, here's one. Thank you. The cost of 1 month of substance abuse treatment for adults in the Des Moines metro area is equivalent to 4 years tuition for the high school class of 2017 in the state of Iowa, which again, I think shows, again, that's a large amount of money. Thank you very much. Anybody else want to share? No one? That's okay. Let me see if I can get back to my screen. Okay. Thank you, everybody, for doing the exercise. Hopefully, you found it to be easy. At least the math part is usually easy. And then hopefully you got into a little bit of practice of how you can find comparative data on the internet. So some ways that I use social math is first, social math is always, I think, enhanced whenever you use a photo with it, if you have space available. Again, it helps the audience picture in their mind what you're talking about. It plays with the context in their mind. And some ways that I've found useful of using social math, first off, with infographics, I think it kind of goes hand in hand with that. A lot of times infographics are so image-based and only have snippets of data. I think social math works really well there. Also, if you have a specific piece of data that you want the audience to take away in a report, like if you have call-out data or highlighted data, I think it works well there as well. Obviously, you need to use it sparingly. You can't use it for every piece of data that you have, otherwise kind of it loses its potency. I think specialized materials work really well with social math. Specific data that you want people to know and are sending out in small doses. The way that I've done this in the past is in one program we send out an e-postcard to the state legislators every year. And again, it doesn't hold a lot of information. We usually put about 2 data points in there, but usually one of those data points is using social math, and that's usually the data point that we really want to get across. Social math, I think, also works really well in social media. Again, it's a limited amount of space that you have to get a point across. And again, it's something that you want people to remember. If you think about all the social media messages that you get, even if you're just on one network, again, this could be the one thing that kind of helps the message stick a little bit more. Also, I think social math is really good for sound bites for interviews or even press releases occasionally. Again, it kind of just helps your data not sound like data. It can make it a little more memorable and stick out. So that's the end of the presentation. I don't know if anybody has any additional questions, but this is my contact information. If anybody, as you're using social math as you move forward and have questions, or just kind of want to show me what you did, I always love hearing how people use social math in the future. So thank you.
Are there any questions for Shayla? Feel free to use the chat box. Okay, seeing no questions, you can certainly reach out to Shayla if you'd like to know more about social math or any resources or have questions for her. She's a great resource, and we appreciate her presenting today, and hope this has helped you with all the data that you use in all of our everyday work and our prevention efforts. So thank you, Shayla, for presenting. Thank you for participating today. Just a reminder that we will send out the PowerPoint presentation as well as the recording of the webinar probably within the next couple days. So you will be receiving that information. Thanks again for participating, and I hope you have a great day.